An oscillating mass has a velocity v given by v of t is 2t cos t plus pi by 2 for t greater than or equal to 0. The velocity is given in meters per second and the time t is given in seconds. A graph of the velocity of the mass's motion is shown below. Determine the first two times for t greater than 0, at which the mass changes direction. State your answers exactly. Well, this is a velocity time graph, so we're looking at where v changes from being negative to being positive, or where it changes from being positive to being negative. In other words, where the velocity is 0 here and here. So we have that t is equal to pi, or 2 pi seconds. What does the signed area of the shaded region in the figure represent? So, we have an area below, which would be the distance that it's travelling in a negative direction, and then an area here, which is the distance travelled in a positive direction. So overall, it's going to be the change in displacement, because overall, it's just going to be this bit here. So that is the change in displacement between t equals 0 and t equals 5 pi by 3. Write an integral expression for the distance travelled from t equals pi by 3 to t equals 4 pi by 3. So there's various ways of doing this, but when you're asked for distance, it's often a good idea to use the modulus, because it cuts out all of the above and below business. So in other words, the modulus would actually just reflect that one up there, and then your area is all going to be above. So we can use the integral, let's say d equals, and we're asked to go from pi by 3 to 4 pi by 3, so let's make sure we get the limits. Then use the modulus, and then the function itself, so 2t cos t plus pi by 2 dt. Determine the first time after t equals pi that the acceleration of the object will be 0. So we need to differentiate velocity. Now you can differentiate it on the CAS, but it's a product. So the acceleration is going to be v times du dt. So that's going to be 2 cos t plus pi by 2. And then u times dv dt. Differentiating cos is going to give us negative sign, so it's going to be negative 2t sine, and then the argument won't change, t plus pi by 2. And as I say, you could do that on the class pad. And then we just want a of t to be equal to 0, so we can just solve on the class pad. So we'll go back to main. Let's just clear all the stuff from an earlier question. And let's get our solve up. And we've got 0 equals, and it will be 2 cos, and I'm just going to use x plus pi divided by 2, and then take away 2x sine and x plus pi by 2. I might just grab it from there and just copy it over here and then close the bracket. And before you hit execute on that, just check we need to be in radians, and then we can execute. It says more solutions may exist. It's not going to be any of the negative ones. So what we're after are positive solutions, but this one's no good because we're after t equals pi. So we're going to be looking after t is 3.14, and we've got this one here, 4.91. The displacement of the mass is given by x of t is a sine t plus pi by 2 plus b cos t plus pi by 2 plus 2t sine t plus pi by 2, where a and b are constants. Determine the value of a and b. Now we know some things about the velocity. We know that the velocity is 2t plus 2t times cos t plus pi by 2. So we can differentiate this expression here. Sine goes to cos, so that's going to be a cos t plus pi by 2. Cos goes to negative sine, so we'll have take away b sine t plus pi by 2. And then if we differentiate this, remember it's a product, so we can do this times this one differentiated, so that's plus 2 sine t plus pi by 2. And then finally, we've got this one times this one differentiated, so that's plus 2t cos t plus pi by 2. And this last part is the velocity. So we don't want this one at all, so we can take a equals 0, and then we would like these to cancel, which they will if b is equal to 2.